The universe is a vast and mysterious ballroom, a place of constant motion and change. It is here that the cosmic dance unfolds, a grand waltz of stars and galaxies. This dance began billions of years ago with a momentous event, the Big Bang. From that initial explosion, the universe expanded and cooled. Out of this cooling emerged the building blocks of stars hydrogen and helium. These elements, scattered across the cosmos, would eventually be drawn together by an invisible force, gravity. Gravity pulled and tugged, gathering these primordial elements into massive clouds. These clouds, known as nebulae, would become the stellar nurseries of the universe. Within these swirling clouds, the stage was set for the birth of stars. A cosmic drama was about to begin, a story of fiery creation and ultimate destruction. Deep within the heart of a nebula, gravity is the choreographer. It pulls the gas and dust together, forcing these particles into a cosmic ballet. As the cloud collapses, it spins faster and faster, like a dancer caught in a dizzying whirl. This swirling motion generates heat, immense heat. The temperature at the center of the collapsing cloud soars to millions of degrees. Under these extreme conditions, something incredible happens. Hydrogen atoms, forced together under unimaginable pressure, begin to fuse. This process, called nuclear fusion, is the heart and soul of a star. It is the engine that drives a star's brilliance, its light, and its heat. With the ignition of nuclear fusion, a star takes its first bow on the cosmic stage. Once a star ignites, it enters a long and stable period known as the main sequence. This is the prime of a star's life, a period of balance and equilibrium. During this phase, the star fuses hydrogen into helium in its core, releasing a tremendous amount of energy. This energy makes its way to the star's surface, where it is radiated out into space as light and heat. The color and brightness of a star during its main sequence phase depend on its mass. Massive stars are like flamboyant performers, burning brightly but living short lives. Smaller stars, like our own sun, are more like steady, reliable actors, shining consistently for billions of years. Even the most brilliant performance must eventually come to an end. As a star ages, it begins to run out of its primary fuel, hydrogen. With less hydrogen to fuse in its core, the star's outward pressure weakens. Gravity, that relentless force, begins to take over. The star's core contracts, becoming denser and hotter. This increased heat causes the star's outer layers to expand outward, ballooning the star into a red giant. During this red giant phase, a star may engulf its inner planets, a stark reminder of the immense scale and power of these celestial objects. Our own sun will eventually become a red giant, expanding to consume Mercury, Venus, and perhaps even Earth. Section 5 Supernova, a star's dramatic exit. While smaller stars fade away quietly, massive stars meet a more dramatic end. They explode in a brilliant burst of light and energy, a supernova. This cosmic explosion occurs when a massive star can no longer sustain nuclear fusion in its core. The core collapses rapidly under its own gravity, triggering a shockwave that rips through the star's outer layers. These layers are blasted out into space in a spectacular display of cosmic fireworks. Supernovae are crucial to the evolution of the universe. They disperse heavy elements forged in the star's core into the interstellar medium. These elements, like carbon, oxygen, and iron, become the building blocks for new stars, planets, and even life itself. Section 6. Stellar remnants, neutron stars and black holes. After a supernova, a star leaves behind a remnant, a dense object shaped by the extreme forces of the explosion. The type of remnant depends on the mass of the original star. Stars that are several times more massive than the Sun collapse into neutron stars. These objects are incredibly dense, packing the mass of the Sun into a sphere just a few miles across. The most massive stars collapse into black holes. These are regions of space-time where gravity is so strong that nothing, not even light, can escape their grasp. Black holes are the ultimate cosmic mysteries, invisible to our telescopes, yet exerting a powerful influence on their surroundings. Section 7. Cosmic recycling. From death comes life. The death of a star is not the end, but rather a new beginning. The elements scattered by supernovae enrich the interstellar medium, the vast spaces between stars. This cosmic recycling process is essential for the formation of new generations of stars and planets. Gravity draws these enriched clouds of gas and dust together, repeating the cycle of stellar birth and death. The atoms in our bodies, the oxygen we breathe, the calcium in our bones, all were once forged in the fiery hearts of stars. We are, in a very real sense, children of the stars. Section 8: Galaxies, islands of stars in a cosmic sea. Stars are not randomly scattered throughout the universe. They are grouped together in vast collections called galaxies. Our own Milky Way galaxy, a barred spiral, contains hundreds of billions of stars. Galaxies come in a variety of shapes and sizes: spirals, ellipticals and irregulars. They're constantly moving, colliding and merging, reshaping the cosmic landscape. These galactic interactions trigger bursts of star formation, adding to the ongoing cosmic dance. The universe is a dynamic and ever-changing place shaped by the interplay of gravity, matter and energy. Section 9: The unending dance. The cosmic dance is a never-ending story. Stars are born, they live and they die, enriching the universe with the elements for new generations of stars and planets. Galaxies collide and merge, creating ever larger structures in the cosmos. The universe is expanding, pushing galaxies farther apart. But within those galaxies, the dance continues. Will this dance go on forever? Or will the universe one day reach a final curtain call? These are questions that astronomers continue to grapple with, seeking to unravel the mysteries of the cosmos.